Note-taking sheet. You got two things to accomplish today. We're going to talk for the first half about what you already know, just a little quick refresher on moles and what they are and what we can do with them and molar conversions. And then for the second half of the lab, or the second half of the hour, Mr. Newbauer will be talking about Friday's lab activity. So I'm going to go fairly quickly because most of this stuff, well, hopefully all of this stuff, you've seen and used a bunch. It was back in Unit 2 that we did moles, but now we're coming back to it with stoichiometry. We're going to take everything we learned earlier in the year and combine it with what we just learned about chemical formulas and balancing equations and giddy up. So, molar memories. Good times. Good times. All right, so if, gosh, darn it forbid, I come across and explain something that you don't recognize and doesn't sound familiar, or you don't remember, please speak up, because we're going to use it. We're going to use it all. So we want to know what's a mole, what's molar mass, and how do I do molar conversions. First, what's a mole? It's a number. It's a counting unit, like a dozen. Except it's not a dozen. It's so much bigger than a dozen. So much bigger than a dozen. Me and Winky are on the same page. It is so much bigger. A mole can be represented with Avogadro's number. And I'm sure most of you, if not all of you, remember Avogadro's number from Mole Day, which was October 23rd. There it is. 6.02 times 10 to the 23rd. 1023, 1023. And how big is it? It's hugely, bigly, humongously, largely big.
Is it bigger than Brazil?
Is it bigger than what?
The number for the
Bigger than the number of Google? I don't know the number of Google.
You said it's not still.
You don't know.
So this far.
Here's how big it is. Boy, if we had a mole of hockey pucks, you know how much mass that would be?
At least 2 tons.
It'd be like at least two what?
At least.
At least 2 what? Be like the mass of the moon. That's how big it is.
Oh my God.
I know. If we had a mole of basketballs, that would be the size of the earth.
That's a lot of basketballs.
If we had a mole of pennies, it would cover the earth a quarter mile deep. What? Yeah. You'd have so much money if you had a mole of pennies. That should be like, it's not going to be, but that should be like an extra credit question to figure out how rich you'd be if you had a mole of pennies.
It's so hard to.
Okay, so it's big. It's a huge number. Here, you'll recognize this immediately as a mole of copper, a mole of sulfur, a mole of magnesium, a mole of tin, and a mole of silicon. Notice that they're not all the same volume. They're not all the same mass, but they are all the same number of atoms. What about molar mass? What is it? It is the mass of 1 mole of an element or a compound. For moles of elements, we get them right off the periodic table. And we'll give you a few examples of that in just a few moments. The atomic mass, which again is the number right off the periodic table, not the atomic number, but the one with the decimal places, tells you how many AMU, atomic mass units, there are for one atom of a given element. That's such a puny, tiny, puny little number. We seldom really use it in class, but we've talked about it earlier in the year. More familiar we are with the grams per mole. So the atomic mass of hydrogen is 1.01 grams per mole, comes right off the periodic table. Atomic mass for carbon, 12.01 grams per mole, right off the periodic table. And our practice is going to be to round all of our calculations to 2 decimal places. Previously in the last unit, when we were doing empirical formulas and percent compositions, we would sometimes go to several decimal places, but 2 decimal places should be sufficient for everything we're going to be doing in this unit. Giddy up. Alrighty, a couple of simple examples. These should look very familiar. What's the molar mass or the atomic mass of carbon? We just mentioned that one, 12.01 grams per mole. Again, it's right here on the periodic table. You look at carbon, atomic number 6, it's got 6 protons, but it's got a mass of 12.01 grams for a mole of it. Aluminum, right off the periodic table, 26.98. There he is. And zinc, again, right off the periodic table, 65.39. 65.39 what? 65.39 grams in 1 mole of zinc. So next, molar mass of compounds. And we just did this in the last unit when we were doing our percent composition and our empirical formulas. So you've done it. I'm just going to remind you what you've done. H2O. So now rather than just looking at the periodic table for one element, we're going to look at all the elements that show up in that formula. There's 2 hydrogen and 1 oxygen, so we're going to multiply 2 times the atomic mass of hydrogen plus 1 atomic mass of oxygen. Same with sodium chloride, except here there's just 1 of each, so we look for sodium, 22.99, plus chlorine, 35.45, add them up, and that's the molar mass of our sodium chloride. I hope you agree this all looks very familiar. If that's true, that's good. It should. Okay, what are we going to do with our molar masses? We're going to do molar conversions. We got a couple of different possibilities. This little diagram should look familiar. We can go from grams of a substance to moles of a substance, or if we know moles, we can figure out how many grams we have. Or if we know moles, we can figure out how many particles we have. Or if we know how many particles we have, we can figure out how many moles we have, and we can go all the way across. Those are like two-way bridges from one island to the next. So if we're going to go from mass in grams to moles, we're going to use a T-chart because we always use T-charts. And we're going to multiply our mass in grams times 1 mole over the molar mass, so that our masses, our grams cancel out, and we're left with units of moles. If we're going the other way, we flip our fraction. So instead of moles over molar mass, it's going to be molar mass per mole. Similarly, going from moles to particles or particles to moles. Those are one-step conversions. We're going from moles to particles. We're going to have particles over moles as our conversion factor, so that our moles cancel out and we're left with particles. And vice versa, if we're going the other direction, we flip our fraction, and it's going to be moles over particles. And that number, 6.02 times 10 to the 23rd, is always going to be the same value as we're going from moles to particles, because that's how many particles there are in a mole. Okay, let's do a couple of simple examples. I got 2 one-step examples and 3 two-step examples, and then we are done. So one of the things we want to do is take out your calculators if you haven't already. You won't need it necessarily for this one, but I do want to make sure that you know how to use your calculators for exponents, for really big numbers. For our first one, this one should almost be second nature, but if it's not, we're going to go through it anyway. 26 grams of carbon, we want to know how many moles there are in 26 grams of carbon. So we look at what we've got, grams, what we want, moles. That's going to be the left-hand side of your little island bridge diagram. We want to get from grams to moles, so our conversion is going to be moles over grams. How many grams? Comes off the periodic table, carbon. Atomic mass of 12.01. Grams are going to cancel with grams. And boom, 2.2 moles of carbon. Shouldn't have any calculator issues with that one. We may with the next couple, because the other ones, I believe, all use Avogadro's number. So how many molecules are in 2.5 moles of sodium chloride? So we're going to start with our 2.50 moles. Ideally, if I'm writing this out, I'm putting 2.50 moles of NaCl rather than just 2.50 moles. Now our conversion factor, because we've got moles and we want molecules, is going to be molecules over moles.
You don't have this on here.
Do what?
You don't have this on.
Is it?
Well, that's a misprint. Took 3 hours to find that out. So this would be the one to the right of the first one that looks just like the second one. So you can replace that second 26 grams of carbon with 2.50 moles of sodium chloride, please. Now this is where things get a little dicey with the calculator for some of us. We do not want to type in 6.02 multiplied by 10 caret 23. Not that you can't do it that way, but that's just going to, the more buttons you push, the more likely you are to push the wrong button with those chubby little fingers. So what we want is to look on our calculator and find hopefully one of these buttons. Times 10 to the n, exp, or EE. Is there anybody that doesn't have one of those 3 buttons on their calculator? These buttons allow you in one press to avoid pushing 3 other buttons. So all of these are short for times 10 to the caret. So here's what we want to type in. Literally, step by step. you're gonna type in 2.50 times 6.02, then hit one of these three buttons. You do not have to hit, we don't want you to hit your multiplication button again. Once you've hit one of these three buttons, then you just enter 23. That'll put your exponent in there, and equals, or enter. And you should get 1.51 times 10 to the 24th. Please let one of us know now if you don't get that answer when you plug that in.
Why is it molded?
Mollies, that's just short for molecules. So many letters in molecules. Everybody calculator savvy? Any calculator issues? Please speak up if you get them. Emily, you got this one? Perfect. We want the mass. We're going to find the mass of, holy buckets, that many molecules of sodium bicarb. So we're going to start with what's given. 2.1 times 10 to the 24th molecules. And we're going to go from molecules to moles. That's going to be our first jump. And then we can go from moles to grams. So for every 1 mole of NaHCO3, we've got 6.02 times 10 to the 23rd molecules.
Why would moles go on top? If you want
We wrote it, we didn't.
number of particles per moles, you have 6.02 to the 23rd over.
What?
Yeah, isn't that right here?
Oh, yeah, that's because I fixed that, and apparently I didn't save it on that previous slide.
So they're flipped around?
Yeah. So,
The arrows are different.
oh, the arrows are reversed?
Yeah.
That'd be my fault. Well, I fixed it.
It's still the same direction, it's just not.
So, yeah, this is,
It's still an error. Yeah, there's still a, I mean,
this
just.
is right though.
Just write it from.
Now,
Just do that.
if we're going from moles to particles, we want to multiply by this many particles per mole. Your arrow, oh, yeah, your arrows are reversed from my arrows. That'd be the problem.
Smart. Not that hard. I don't even, it's like scribbling his whole paper. No, I'm not, I wrote arrows.
Okay, so let's just take a moment, make sure we've got our little island map correct.
That's awesome too.
So, if we are going from moles to particles, we want 6 times 10 to the 23rd over 1 mole. And if we're going from particles to moles, we want moles over 6 times 10 to the 23rd. So you might have to reverse your arrow. For that, I apologize. I corrected that in the last 2 classes, but when I corrected this, somebody told me that their arrows were pointing in the wrong directions in the previous classes. But, does that make sense now, Bailey?
Yeah.
Okay. Thank you for letting me know that was wrong, so hopefully the fourth time we do this, it'll be really right. Okay. So, we've got molecules, we want grams or mass, so we're going from molecules to moles first. Then we're going to go from moles to grams. And for this compound, we've got 84.01 grams in 1 mole.
Is that from adding up all the?
Yep, that's from the mass of sodium, 1 sodium plus 1 hydrogen plus 1 carbon plus 3 oxygen.
Okay.
And then when we plug and chug through, and we use our one-stop calculator button to avoid our fat finger mistakes, we get 293 grams, which with 2 significant figures is going to round back to 290. But if you got 293 times, or 2.93 times 10 to the 47th, or 10 to whatever, other than 10 to the second, then we got calculator issues. Ready? Okay, we're going to stick with sodium bicarb. So the molar mass is going to be 84.01 again. This time we're going to start with 10 grams. And we want to find out how many molecules we have in 10 grams. So we start with our 10 grams, and we're going to go from grams to moles. And don't cross out 84.01, cross out the G. Then we're going to go from moles to particles, or moles to molecules. And then we're going to plug it all into our calculator. 10. I don't know how my lines got shifted. So 10 times 1, you don't have to do that, times 6.02 times 10 to the 23rd, divided by 84.01. And you should get 7.16 with a bunch of digits, times 10 to the 22nd, which will round to 7.17 times 10 to the 22nd. I'm going to assume, since no one had any issues previously, that we're still not having issues with our exponents. Last one. Caffeine. 27.5 grams of caffeine. We want number of molecules. That would be quite a dicey little one to have to work out for you, so I'm going to give it to you. 194.22. And you finish, please. Yep, you finish this one, please. Plug and chug, let me know what you get.
Okay, what you get, I did this backwards. You're supposed to go. Try here. so much.
What exactly am I trying to accomplish? What am I trying to accomplish?
So our grams cancel in the first step, our moles cancel in the second step. 27.5 times 6.02 times 10 to the 23rd divided by 194.22, 8.52 times 10 to the 22nd. Sig figs, we got 3 to start. We're going to round our final answer to 3. All good? It's nice being taught stuff you already know. Easy.
Sure is.
We're going to take this and ramp it up a couple of levels in the next few days, but it's going to be the same, only different than what you've already done.
I know you know, it's like proclaim the special ed. You were not in my reading. This is so garbage.
That's why you don't get it all in.
Oh my God.
All right, ladies and gentlemen, we're not done right now, so we still need your attention. You need to be quiet, okay? Right now, Mr. Blackford is passing out your homework. That's going to be due on Friday, and you are also getting, gentlemen, you can figure it out. I'll talk to each other, okay? Oh, my bad. Thursday. So it's due on Thursday. The other sheet that you're getting is the lab, and you are getting the Brownie pledge, which I am going to go over shortly. Okay? So you need all 3 of these things. The mole review and the note sheet from today can get put away. You're not going to need those anymore.
I didn't actually go pick it up. Yeah. I remember, but I know it was okay. But I didn't get that star. But you know if by your score it has star by it, you get if your name was Nicole,
Once they took them from you.
All right, ladies and gentlemen, I need your attention for the rest of the time. Okay? Thank you. All right, so Friday, we're going to be doing the Brownie Lab. It's a fun day, you guys, as long as you do all the things that we're telling you to do and you cooperate with us and you act appropriately, okay? So what we're going to be doing is, well, I guess what you're going to be doing is you're all going to need to make brownies for class on Friday. Okay, so your assignment for tonight or tomorrow night is to literally make a pan of brownies, bring them into class. We're going to be doing those in lab on Friday. Now you're going to have the opportunity to either work by yourself or work with another person. Like the more brownies that we have, basically, the better. So if you're comfortable making your own, like I would suggest that you do, and not partner up with somebody. But if you want to partner up, that's fine. Now, right away, I'm going to tell you, there's no groups of 3 at all. Okay, so don't ask us if we can do a group of 3. You can't. Okay, can't do groups of 3. You cannot do anything but the recipe that we give you. So there's a recipe on your lab sheet. That's the recipe that you have to use to make these brownies.
Not Grandma Mimi's old recipe.
Right. Can't. What? What did you say?
So what happens when you run into this garbage?
Well,
What? Donald couldn't use this. I saw it. Same brownie. No, it's bad recipe.
Ladies and gentlemen, when did I say talk right now? You can handle this. I believe in you. You can do it. You can be quiet for the next 15 minutes, probably. If you can't, I'm just gonna start moving people. It's fine. I don't really care. If your feelings get hurt, honestly, not a little bit. Okay. Okay. So you need to use this recipe. Okay. The catch is that we are going to change some of the ingredients for each of you. Okay. So there is a point to this. There's a purpose. We're not going to get into the purpose today. It doesn't matter. For right now, all you need to know is that you are going to make brownies. Now, you're going to each alter one ingredient, or you could get the no change. This is the ingredients that could be changed up there. Now, it's important to note right away. All these are already ingredients in your recipe, okay? So if it says a 1/4 cup of butter, you are doing a 1/4 cup of butter instead of, I think it says a 1/2 cup, right?
Yeah.
Yeah, so you're doing that instead of a 1/2 cup, not in addition to the 1/2 cup. So that alternate ingredient replaces the ingredient that's on your sheet. Okay, so in a little bit you're going to come up here, you're going to be taking an altered ingredient based upon your class on Fridays. So you might have to take a look at what that is because you're so used to your Monday tour, but when you come up here today, you got to go by your Friday class because we're going to be doing this obviously Friday, so we need to have the appropriate brownies for each class. Okay, you are then going to be filling in your brownie pudge as well. Your brownie pudge has some rules on it. Okay, the rules are you cannot change the recipe in any way, so you need to do exactly what it says in that recipe. So you cannot add ingredients or steps, and you cannot remove ingredients. Okay, adding ingredients applies to anything, you guys. You can't put frosting on top. You can't put powdered sugar. You can't put nuts. You can't put something in there that you think might be funny. Seriously. Like, there's never been an issue with this. Guys, if that is an issue, you will be punished as severely as we can. Like, as befits whatever you put in the brownies. Okay, so don't screw around with it. Like, we and everybody else in here is going to try, well, yeah, it's not everybody else in here, but everybody in your class that day is going to be eating your brownies. So we need to all be able to trust one another and know what you're putting into somebody else's body. Okay? So you just be appropriate with this. Okay? And it shouldn't. It hasn't ever been an issue. It won't be an issue. But that's just why we're doing that. Okay? Number 2, you can't use a box recipe. Like, it's obvious if you use a box recipe versus the recipe that we've given you. And we'll be able to tell the difference. Okay? After you sign up today, you cannot change groups. So you're going to make a commitment today to what you're doing. The reason we have done this is because today, so whoever decides that they're going to go by themselves, well, tomorrow they find out that Dustin already made his brownies. So I'm like, well, you know what I'm going to do? I'm going to jump on with Dustin now and not have to make brownies. So that's why today you're making the commitment to make the brownies, not jumping on with somebody else tomorrow. Like, there's no questions asked about that. If you come up to me tomorrow, or Mr. Blackford, or Mr. Gussie, and you're like, can I work with whoever now? No, you can't. Like, bottom line. And if you do that, you're going to lose all the points in the lab. It's just that simple. Okay, we're not screwing around with this. So you got them. If you sign up to make them today, you sign up to make them. What's your question?
So the brownies are due Friday.
The brownies are due Friday, yes. So we're going to do it Friday. Now, if you want to work with somebody that's in your Friday class that's not in here yet, I'm sure that some of you have probably already heard about this today from people that were in an earlier class. So if that is the case and somebody from an earlier class is working with you, that means that they already grabbed the altered ingredient. Do not grab another one right now, okay? What you need to do is if they signed you up already, then you need to figure out what their alternate ingredient is that they picked for your group, right? And you write that one down in your brownie pudge. Everybody still has to turn a brownie pudge in, but you're just not going to come up here and grab another altered ingredient, okay? That being said, if you're on the other side of that, so if you want to work with somebody that's in 13-14, which is our next class after this, it's fine. You can text them now, whatever, if you want to, but you need to let them know what the alternate ingredient is, and they need to know that you're working together. So if that person comes in here and you didn't tell them that you were working together, like you just assumed it was a given, and they pick an alternate ingredient and they signed up on their sheet that says that they're doing something, then they're doing that one and you're doing yours. Does that make sense? So there needs to be communication between the two of you so you guys are aware. And that person has to be in your Friday class. You can't do it with somebody that's in Blackford's 1, 2 that has meat, I don't know, 11, 12. Just because we're gonna eat the brownies during that time. Okay, so they have to be there obviously during that time. Okay? Does anybody have questions on any of that stuff? Okay, so in a minute, well, sorry, I have other rules. I think I went through these before, but no frosting. You only alter the ingredients that you choose. You can't switch groups. Oh, the other thing that I want to say, you can cut your brownies at home, but we need to know your pan dimensions. So some of your parents are not going to want you to take their pan or baking dish or whatever to school on Friday. Okay? So what you can do is you can cut the brownies at home. And if you're going to cut them at home, you want to cut it into, I don't know what, 28 pieces I think we said, roughly. So about 28 pieces would be good because some of the classes are 28 people in the class. So cut it into 28 pieces. You can put it on a paper plate, in a Tupperware, whatever you're going to bring it to school in, but we just need to know the pan dimensions. So if it's 8 by 10, 9 by 9, whatever you make it in, we need to know those dimensions. Okay? All right. I think that's it. So, what you need to have for Friday, you got to have your brownies made for Friday, and you need to have that Brownie Lab data table in your lab notebook. That's it. There's not a pre-lab, there's not a write-up. The only thing is that data table. Okay, so you have the data table on the top right. You're going to need at least 25 rows. Okay, because assuming that in some of the bigger classes, if everybody did their own, that'd be 28, right? So you're going to have 25 rows in there, so you're literally going to put that same thing each time because basically we're going to have a rating system for when we taste the brownies and stuff that we're going to do for each different brownie. Okay? So just those two things for Friday. And then obviously your mole review for tomorrow. Okay? So in a minute, you're going to come up here, you're going to get an alternate ingredient. What you are going to do with that alternate ingredient, you're going to put it in 2 spots. You're going to write it on the sheet that is your lab that you're going to keep and take home, so then when you take it home you know what ingredient you are changing so you can make yours the right way. And you're also going to put it on the bottom of your brownie pledge because those brownie pledges are going to get turned into us today, and it's just to let us know what you are doing. Okay, so it's an accountability thing for both of us, okay? All right, you also need to put your name on here. So you're going to sign it and you're going to put it on the bottom. You're also going to write it up here where it says, I print your name, do solemnly swear, and it says all that stuff about the Brownie Lab that you're going to do and you're going to be appropriate and all that good stuff. Okay, so we can all have fun on Friday. It's one of the most fun labs of the year, you guys. So if we all act appropriately, it's going to go really well. All right? Your partner's name is going to go down there. So no matter what, everybody is filling out a brownie pledge. So you put your partner's name down there, your name goes in all those spots. Alternate ingredient down there, I think that's everything. When you come up here now, make sure that you're grabbing from the appropriate beaker, like they're all labeled. It goes Newbar 5, 6, 7, 8, 11, 12, 13, 14, Blackford, and Gussie. Now this is not, I'm going to repeat again, this is not your tour. Okay, this is your Friday class. So right now, before you even come up here, on top of your brownie pledge, please write the teacher you have for Friday, not your tour, and the mods that you have that teacher. On your pledge, yes. Just in case they get mixed up, Dustin, when I'm going to go through and put these down. That's all. Okay? All right. Then, when you come up here, you're going to grab an alternate ingredient. Guys, there's only one way that you can pick a different one. All right? So you pick, and you're going to have to do the one that you choose. All right? Unless you get the one that says no change, and you're a terrible cook / baker / whatever. Okay, if you do not feel confident in making the ones that are no change, because we need to have a baseline that we're comparing the other ones to. Okay, so we're gonna have some no changes. If you know that you're probably gonna mess the no change up, then put the no change back and grab one of the other ones. Okay. All right, that's it. That's the only other rule.
You know, if it says 2 eggs or like 4 eggs, it's not 4 plus 2.
Yeah, I told him that. Well, it's probably good to say. Yeah, I did. Thank you. Okay, let's do the first 2 rows. First, you're going to come up. You're going to grab one of the alternate ingredients. Hey, oh, one last thing. The alternate ingredients, when you're done with the slip, you can just toss in here. Please don't put it back in the beaker because we want to have different ingredients. So make sure you get it written down. Then you can throw it in the recycling here, okay? All right.
I have to write it down. Oh, wait, got it?
What?
I need to write that.
Oh, yeah, you can write that on there, yeah.
Newborn classics. Hey Haley, can you grab me a 7-8 Friday bar?
Friday.
Whoa.
Back up fast.
Oh, Lord.
Don't mess it up.
You're fine, kid.
Oh yes, sugar. More sugar. Probably gonna be good.
Dude, stars. You don't know your backup was? Oh my gosh.
Next rows, can you go?
Who said my name? Yes, Dustin.
Where are you on Friday, Taylor?
So we don't put that in?
This is what you're going to use
don't want that
instead of what the sugar is on the
I
regular.
want that one.
No change?
What do we put in?
That can go here. This is where you drew from. That can go in the recycling, and your name should also be down here.
Is this one done? Ooh, that's a lot of fun. You put them back in, right? I was not in my 7-8 class.
Oh, yeah, this is... Okay, I got you. It's probably... What the heck?
I don't know.
Mr. Blackbird, why does Emily have the same one as me, but I got this one?
Do you throw these away? Yeah.
Are you pulling from 11-12?
Yeah.
Because probably one of you isn't actually in 11-12 on Friday.
Emily,
Emily,
what class are you in Friday?
where's your little strip? Oh, where is it?
Okay, then I'm not doing this one. Half a cup of sugar, isn't that like nothing?
One cup of butter.
Love butter.
Yeah, who doesn't? Where do I put this thing?
Really?
Got it.
And where do you write it?
Sorry.
And then where do you put it?
Guys, as we're making this, you may not be professional
That's your
chefs.
Friday, right, Francis?
Guys, I want to share 2 stories that happened in the same hour about 8 years ago. So they were eating these brownies, and they're like, "Oh, you got to try these." And everyone's face coming away from this one group was just like, I mean, like the mouth was on their forehead, and their eyes were in their ear. I mean, it was just like they were deformed. Everybody was just like, they couldn't handle these brownies. I'm like, it can't be that bad. Like, you got to try those. And I took a bite into it, and I felt like someone like just like Ronda Rousey just took it right into my nose, and I'm gone. And I'm like, whoa, what was that? And they're like, I don't know. I had an alteration. It was like vanilla or something like that. I'm like, what is wrong? Like, I used everything right. I'm like, holy cow. She's like, well, I used a quarter cup of salt. And if you look at the recipe, it's a quarter teaspoon of salt. But, well, I thought it was kind of high. But make sure you look at units. So then, this is the best part, it's in the same hour. Someone else is like, you gotta try these. I'm like, it can't be as bad as that. Although it wasn't as bad, it's very different. Take a bite, and I'm like, why is it crunching like there's Doritos in it? I mean, like you can hear other people. I'm like, what is going on? And the guy's kind of laughing about it, and he's like, well, mine's really scientific. And I'm like, what does that mean? I'm like, what? I read between the lines. I was more scientific than everyone else. It said 2 eggs. And I look, and I see all these little pointy things all over, and they're kind of white. Well, it didn't say anything else. It said 2 eggs, so I threw in the 2 eggs. So it was full of eggshells. So I guess don't try to read in between the lines so much. It's not like, oh, vanilla, and you just throw the bottle in. Let's be a little smart about this. Use your parents as guidance if you need some extra help. But anyway, they happened the same hour. All the rest of the things.